certain rule that has been, or the certain rules used in formulating this sequence from 16 to 81. So you can determine the next terms after 81, the next terms, and then the next terms, the next is second terms after 81, the next is third terms after 81, the third 80 terms, the first 80 terms after the 81. That's the meanings of this sentence. The pattern can be discovered by examining three or more consecutive terms. Three or more consecutive terms. Three or more consecutive terms. Three or more consecutive terms to see how they are related. To see how they are related. See how they are related. For example, the next terms for the sequence. For example, the next term for the sequence 1, 2, 3, 4, 5 must be that sequence must be 6. Why? Because the difference between these terms is 1. So let me explain in brief what are the explanations. We say the terms of the sequence can be extended if the patterns govern the given terms can be formed. The rules. For example, these are the multiples. If you take this, if you take 9 multiplied by 2, you get 18. If you take 9 multiplied by 3, you get 27. If you get 9 multiplied by 4, you get 36. If you take 9 multiplied by 5, you get 45. So it means that the next term, which will be 9 times 6, which will be 54. So you can determine other next terms by using the rules that have been used to formulate the first, second, third, fourth, and fifth, 30, and 50 terms of this sequence. Again, she said that the patterns can be discovered by examining 3 or more consecutive terms. So how do we discover that patterns? Okay? So the patterns or the rules, we discover the rules by using either the first series, 1, 2, 3, or more than 3 consecutive terms to see how they are related. What are their relationships? For example, the next term for this sequence 1, 2, 3, 4, 5 must be 6. And then the next terms after 6 must be 7. The next terms after 7 must be 8. Why? Because the difference between the first term and second terms is 1. And the difference between the second terms and third terms is 1. And the difference between the third terms and fourth terms is 1. And the difference between the fourth term and the fifth terms is 1. So that's the rule has been used to formulate this pattern. Right? In case you have any question, please don't hesitate yourself. Ask in the comment section. So let us go to the second example. Okay? I'm still teaching you. Tell your neighbor that Olenjolai is teaching you the concept of the sequence and the concept of the sequence. So let us go to second example. The second example, we say that let us test our mind if it is already understood what I've been teaching about the patterns or the rules that used to form the pattern. Find the fifth stem of the sequence. Find the fifth stems of the sequence 1, 4, 7, 10, dash, 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 dash. Solution. Question is very simple. Find the fifth stems of the sequence 1, 4, 7, 10. This is first term, second term, third term, fourth term. That's why the next is the fifth terms. So you can use this simplest way. 7, you have 4, you have 7, you have 10. So what the difference between first term and second term is 3. Then what the difference between the second terms and the third term is 3. What the difference between the third terms and the fourth term is 3. So therefore the next term also will be the fourth term plus, so it will be the fourth term plus 3 because 3 is the difference between the terms. So 10 plus 3, so the fifth term for this case is what? 13. So the fifth term is what? Is 13. If you have any question, don't hesitate yourself to ask in the comment section. So the fifth term is 13, and that's the end of that question. So let us go to the third example. Number 3. Given the sequence, and this example 3, you have to refer the book of Secondary Basic Mathematics by TAYAI. Given the sequence 2, 4, 6, 8. Find the first term. Then B, the first term. First term. Then Ch, the nth term. Nth term. So we have Roman the first term, the nth term. So this one, try it yourself. Do it at homework. Solution. Given the sequence 2, 4, 6, and the 8, find the first term. The first term is already given in the sequence. So the first term, this is the first term. The first term is 2. No hassling. Then let us do for B. Yes, let us do for B. The first term, that's okay. So this is should remain as your homework. And then let me add D. We say that you find the fifth term. Find the fifth term. So let us go for D, and then she'll come to C, the fifth term. The sequence is 2, 4, 6, and 8. So we have 6, 4, so it's a sequence of even numbers. 8. So to know the fifth terms, you have just to know the difference between first terms and second terms is 2. And the difference between the second terms and third terms is 2. And the difference between the third terms and the fourth term is 2. So even the difference between the first term, so let's say 6 terms, challenge you. So even here the difference is 2, so it will be 8 plus 2. And then the difference between the fifth term and the sixth term should be 2. So 8 plus 2, it is 10, so it will be 10 plus 2. So therefore we say that the sixth term of that sequence is what? Is 12. So we go for Roman C. Roman C, we say the nth term. The nth term, we say that should identify it by using the particular patterns. And this is the pattern. The nth terms, you have to analyze the terms that the first term. So for example, if you take the first term 2 times 1, you get 2. Then if you take the second terms 2 times 2, you get 4, which is the second term. And then you take the third terms, which is 2 times 3, you get 6. And then you take 2 times 8 times 4, you get 8, that's the first term. And even the fifth term is 2 times 5, you get 10. And then the next term is 2 times 6, you get 12. So you continue, so you find 2 is common. So for example, the next term is 2 times 7, which is equal to 14. So 2 is common. And then you multiply by n is natural number, 1, 2, 3, 4, 5, 6. So because it does not have n, so you say that it will be n. So 2 times n. So the last term, is equal to 2 times n. 2 times n. So if that's the case, you say that therefore the nth term for that sequence is 2n. 2n. That's the nth term for that particular sequence. Again, we still have the last example for this session, and this is example 4. In this example 4, we say that find the next 2 terms in each of the following sequence. Find the next 2 terms. Find the next 2 terms. Find the next 2 terms in each of the following sequence. in each of the following sequence. Each of the following sequences. So Roman A, you have 2, 5, 8, 11, 3 dots. B, you have 4, you have 2, you have 0, you have -2. This is your homework as the second question. Then we have Roman C, 1/3, 1/6, 1/12, 1/24. So that's the question. So when we solve, I left you 2 questions for you to do as your homework. Of course, you have to test yourself if you've understood what I've been teaching you. Solution. So we have 2, 5, 8, 11. So we have to identify the rule which has been used to formulate the sequence. So for Roman A, you have a sequence of 2, 5, then 8, 11. So what the difference between 2 and 5? 3. What the difference between 5 and 8? Is also 3. What the difference between 8 and 11 is 3. So even the next term here, the difference between the next unknown term is 3. So for this case it will be 11 plus 3. And even the next term after this term, the difference between the fourth term and the fifth terms will be 3. So 11 plus 3 is equal to 14, and then 14 plus 3, so here it will be 14 plus 3. So the next 2 terms, for that case, will be 14 and 17. 14 and then 17. So therefore, the next 2 terms. Next 2 terms are 14 and then 17 are the response for Roman A. Then for B, that's your homework. For C, we can do it together. Can help you because this fraction, you might be frightened it at Olenjolai has never taught me about fractions or sequencing fractions. So how can I do it? So this is 1 to 24. So regardless whether the sequence is in fractions or decimals, don't worry. The same rules will be used like in case of whole numbers or integers. So for this case, if you examine this sequence, it's a fraction. It has 2 parts. Numerator, denominator, numerator, denominator, numerator, denominator, numerator, denominator. If you examine, you find that numerator is a constant number, which is 1. And then if you examine denominator, it has been formed by following a particular rule. This is 3, this is 6, this is 12, this is 24. So it means that 6 has been obtained by taking 3 times 6, no, 3 times 2. 12 has been obtained by taking 6 times 2. And then even 24 has been obtained by taking 12 times 2. So what do we say? What the difference between them? So if you take that, if you examine, there's a rules that have been formulated that, for instance, for this case, you say that the second term, which is 1/6, this has been formulated by 1/3 times 1/2, right? Then the next term, the third terms, which is 1 over 12, it has been formulated by taking 1 over 6, then multiplied by 1 over 2. And the next term is 1 over 24. This has been obtained by 1 over 12 times a half. So a half is common. So even the next term right now that we don't know, maybe equal to term x, we'll take the first term, which is 1 over 24, we multiply with 12, 1 over 2. So the answer, 1 over 24 times 1 over 2 is 1 over 48. So that's the next term. Again, here we go. We take the fifth term, which is 1 over 48, we multiply by a half. So if you multiply, we get that 1 over 96. So the fifth term will be 1 over 48, and the sixth term will be 1 over 99. 96, not 99. 1 over 96. Right? So if that's the case now, if that's the case, you say that for Roman C, we say the next two terms. The next two terms are 1 over 48 and the 1 over 96. That's the response for that question. I left you 2 questions for the homework. Make sure that you do before this said session, and in the said session I'll be solving more examples or more questions concerning about the concept of the sequence, because I want you to understand the concept of the sequence before I teach you the concept of the series. So make sure that you go through this material and you revise them. In case you have any question, please ask in the comment section. Make sure that also you subscribe onto our YouTube channel that called Tanzania Online O-Level Seki Schools, in square bracket is Olenjolai. So for the YouTube community to give you notifications at any times when we upload a new video. So in case also you want to offer your Thanksgiving, please go to the descriptions of this video. You will find a two alternatives by using the bank accounts or by using the mobile transactions for Thanksgiving. If you want to offer the Thanksgiving to make sure that the more lectures of sequence and series or more lectures of basic mathematics you will be in air, or will reach anywhere and at any times wherever that you are in the world. So thank you very much. I thank God for giving me this opportunity to teach you. Join me in the session 3 of sequence and series. Join me even in some other sessions of physics and even chemistry for all level or for ordinary secondary schools. And make sure that you invite your friends, and you should take this material seriously. And then may God bless you, and make sure that you go through this material. May God bless you. See you in the next lecture.